Good evening, everyone. Welcome to O-level physics lessons on the current of electricity. Today is our second lesson on this topic. Today is 12th of April, 7:30 p.m. Okay, last week I've gone through a summary of this topic, and today we'll just go through the notes quickly. Okay, so we'll go through in detail what you need to know. Okay, last week we went through what are the objective of the topic and I started teaching. Okay, so for today, we will go through the notes proper. Okay, but actually it's similar to what we did last week. Okay, but in a proper notes form. Okay, so let's begin. And all of you have also given me your formulas of these three formulas that you need to know for this topic. So I am pretty confident that I will not spend too much time on the notes. Okay, just going through what is important. Okay, first of all, this topic is broken up into three parts: current, volt, and resistance. Okay, and for current, all of you need to memorize this. Okay, current is the rate of flow of electrical charge. And last week I will emphasize, when you see the word rate, it means divide by T. So in physics, there's a couple of formula that has divide by T in their formula. For example, power, okay, velocity, speed, acceleration. Okay, all these has divide by T in their formula. So their definition is always rate of something. So in this case, you look at the formula, current is the rate of the Q. Okay, rate of Q. Q is charge. Okay, so current is the rate of flow of charge. Is that clear? Okay, and then we use the ampere as the unit. Okay, when you spell it out, it's small letter. When you put it in a symbol, it's capital letter. And to measure current, there is this machine or this tool that you can use. We use an ammeter and you put it in series because the current flow through the wire. Okay, it's how much current flow through at that point, okay, per second. Okay, so you must put the ammeter in the path. Okay, so the ammeter is in series. Do you understand what I'm saying? Because I remember when I was in secondary school, it's always about memorizing because secondary school is always confusing why some of the machine is in series and why some of the machine is in parallel. Okay, so as you know, the definition of current is how much charge is flowing through that point every second. Okay, so you must put the machine along the path. Is that clear? Okay, so the ammeter is always in series. Okay, next. Okay, this symbol thing is not very important now. You'll be covered more in detail next week, but I will just go through a few of these in a while. Okay, then we have also mentioned about conventional current versus electron flow. Okay, in all our drawing, our calculation, our diagram, it's all based on conventional current. Conventional means plus go to minus, or north go to south, or high go to low. Okay, this is conventional. Okay, when you drop something, it drops from a 5 meter height down to 1 meter height. Correct? It's plus go to minus. A big number go to a small number. Okay, so for conventional current, everything that you do in your diagram, your calculation is all conventional. It's all plus to minus. And conventional is means that it's a positive charge that is moving. Okay, but we all know in chemistry that that is not true. Okay, that's not true. It is the electron that move. Okay, so therefore the electron flow is the opposite of conventional current. Okay, so electron flow is just for your info. What actually happened inside the wire is which direction the electron is flowing. But in all other things, your calculation, your diagram, everything else is all based on conventional current. Okay, now circuit symbol. Okay, switch. I think all of you has no problem, right? Switch, cell. Okay, the plus and minus is not important. Okay, the long line is always a plus. The short line is always the minus. Okay, so these four things here, they are called the source. Okay, hold on for a while. Okay, so this 4 is an electric source. Okay, so remember I told you about source and load. Okay, for source, you want to measure the voltage, is called the EMF. Then for the rest of the item, the component, they are the load, they take up energy. So they are the PD. Okay, so what's the difference between DC and AC? Anybody know? Or anybody wants me to explain the difference between DC and AC? Okay, what does DC mean? DC stands for direct current. AC stands for alternating current. Okay, so let me explain this a little bit to you all. DC current is where, okay, so both of these are source. They provide energy to your electrical energy to your circuit. So what is DC current? DC current is where your source, where your potential is always maintained at a stable level. So I give an example of a DC source, direct current. So we have this thing called a battery. Okay, the common battery, all of you will know, will be a 1.5 volt battery. Okay, the very simple AA battery or the AAA battery, the potential difference, or sorry, the EMF is 1.5 volt. Okay, so this 1.5 volt is constant throughout. It may degrade over time, maybe like become 1.4, 1.3, but it's always at that level, 1.5. So if I were to draw a EMF versus time graph, is always stable at 1.5 volt. Okay, that is for a DC, a direct current supply. Is that clear? So for this battery that has an EMF rating of 1.5 volt, if I were to measure the EMF over time, it will always be at 1.5. Okay, of course, after a long time, it will not be 1.5, it will be 1.4 and so on. Okay, but it is direct, it is stable for a long time. Okay, however, for AC, if I were to draw an EMF time graph, okay, it will look like a sine graph, like this. Okay, you have learned in Emax and Amax. It will look like a sine graph. Okay, let me share with you where do we find alternating current. Okay, so the EMF, the voltage of the power source will go up to a maximum, then it go to 0, then it go to the negative maximum, and then 0, positive, and then down. Okay? Hold on for a while. Okay, so where do we find an alternating current source? Okay, at home, we see the 3-pin plug. Okay, at home at the 3-pin plug, the power supply by the 3-pin plug, when you on the power, is alternating current. It's actually going up and down, up and down, up and down. Okay. The EMF or the voltage, I use the primary school terminology. The voltage supplied by AC is going up and down in a sine wave. And in Singapore, the maximum it will go is 240 or 230 volt. And the minimum it will go is 230 volt. Okay, that's in Singapore. And then how many times, how many sine wave does it occur every second? Okay, in Singapore, it is at the rate of 50 hertz. Is that clear? So when you go out and buy something, nowadays, a lot of people buy things online. Especially you want to buy things from Taobao or now Shopee, Lazada. A lot of things are being shipped in from China. So in China, does the power supply, is the power supply same as Singapore? Okay, it is different. Okay, let me check. What is the China power supply? Okay, so before you buy something, okay, you need to check that whether does it whether the hold on. Yeah, you need to check whether the power, the AC power of your item, whether you're buying your charger or your camera charger and so on, whether does it fit into Singapore. Okay, so when you buy things that's able to fit in Singapore, you must make sure that our Singapore voltage is 240 and then the frequency is 50 hertz. 50 hertz means that there are 50 complete sine wave. happening every second. Okay, so that is for Singapore. Imagine if you buy things from USA. USA is not 240 volt, it is 120, if I don't remember wrongly. Okay, so when you buy things overseas, always make sure that it's compatible to where you're going to use the equipment. So in Singapore, you make sure that it's 230 to 240 volt, and then the frequency is 50 hertz. Anything that's off, we plug it into our power supply. It may cause a short circuit in your house, or it may actually burn your device. Okay, so this is something that all of you need to take note. Okay, so just a feedback. Is this AC thing something new that you listen, that you hear for the first time? If something new, give me a yes reaction. If it's something not new, give me a no reaction. I just want to have a feel whether if this is the first time you heard about it. If it's the first time, okay, so half of you say it's the first time, half of you have heard it before. Okay, so Yi-Ting asked me a very good question. Why the current need to alternate? Okay, so as you can see over here, first of all, the term you use need to change. Okay, the term you use, you need to change, Yi-Ting. Why I say change is because you look at the graph that I'm drawing. It is an EMF graph. It is not a current graph. Okay, so you should ask me why the EMF need to alternate. Okay, not why the current need to alternate. Okay, let me go through some history review. One of the first inventor of residential electricity, right, is Thomas Edison. How many of you heard of this guy before? You heard of Thomas Edison? Give me a yes reaction. Okay, he is famous for many inventions, but the most famous invention by Thomas Edison is the light bulb. Okay, so in America, when Thomas Edison invented the light bulb, okay, he also found a company called General Electric in USA. So he is one of the first scientists or inventor that tried to supply electricity to the cities. Okay, because in the past, when there's no electricity, you need to use things like candle and so on. There will be also no machine, no fan, no aircon. Okay, so Thomas Edison, his company General Electric, tried to supply electricity to the masses. Okay, and the easiest way that we know, I mean, if you look at the two graphs, which one is easy? The straight line one, DC, or the alternating? Okay, based on what you see here, definitely DC is actually more straightforward, am I right? Okay, just maintaining at 1.5 volt or 200 volt, for example, and you just supply to your houses. Okay, however, DC power degrade over long distance. So for example, if your power plant is far away from your residential area or your commercial area or even industrial area, you lose a lot of electrical power. Okay, that is if you use DC. Okay, so DC actually started off without a very long life because it is not efficient at all, especially over a very long distance. Then the other scientist, okay, I think you heard of this guy before. He's called Tesla, Nikola Tesla. Have you heard of him? Okay, he's the one that used AC current or AC circuit or AC, AC current and supply AC to the houses, okay, to the offices and the industry. And AC current actually will have less loss over a long distance. Okay, so because of efficiency issue, eventually in town, in cities, in all over the world in town, we are using AC alternating current. Okay, we think, did that answer your question? In O level, you need not explain why is AC important. Okay, but that is a history why now we are all using AC. You think okay? All right. Okay, so that is the difference between DC and AC. And then because AC is a sine graph, it goes up and down in Singapore 50 times every second. You see like this symbol here. Clear? Okay, next. Next thing, light bulb. I'm sure you learned this in primary school, so I will not go through the light bulb. Okay, potentiometer is similar to a voltmeter. Okay, so I've gone through these two before, ammeter and voltmeter. Okay, I've gone through these two. So potentiometer, let me see. Yes, potentiometer is similar to a resistor. Sorry, it's similar to a resistor. I'll talk about it next time. Okay, now we talk about the. Can we talk about a few other things first? We talk about the fixed resistor. This one. A fixed resistor itself has a fixed resistance. Okay, for example, 10 ohm. Okay, the resistor is fixed at this value. Whereas the rheostat is also a resistor, but the value can vary. Okay, so a variable resistance looks like this. It's the same as a resistor with an arrow cutting through. Okay, so this is a variable resistor where the resistance can change. Okay, this one, the resistance can change, whereas for this one, the resistance is fixed. That's why it's called a fixed resistor. Okay, next. Wow, hold on. Hold on for a while. Let me clear a few things. Too messy. Okay. So this one, wires join and so on, I did not go through. It's actually self-explanatory. Okay, wire cross means the wire that's horizontal wire itself doesn't join with the vertical wire. So you actually do a bridge over it, like a jump. So this horizontal wire does not connect with the vertical wire. So this is called a wire cross. Okay, so far? Then, I mentioned earlier on, ammeter must be in series to measure the current. Voltmeter is connected in parallel to measure the potential difference. Okay, you will hear a lot of this thing called galvanometer as well. Okay, galvanometer is the same thing as an ammeter. It's a simple ammeter. It just detects any presence of current. It doesn't measure the value of the current. Okay, so basically it is the same as an ammeter, but it just measures whether it's that current or not. So for example, if you put this galvanometer along the circuit, if there's a current going through this arrow, the meter will move. So when the meter moves, means there's current. The meter doesn't move, there's no current. Okay, so this is called a galvanometer. Galvanometer, okay? Next, the switch here, this is the switch. And this is a special switch where it is a two-way switch. Okay, this one I think is also self-explanatory. Anybody need me to explain this two-way switch? When it's point to one direction, it's connect to the first one. When you join the second one, you'll be connecting to the second one. Okay, so far? All right. Now, the rest of the item, okay, let me talk about this one first. This coil of wire, okay, I'm sure you've seen this before, even in primary school. When we talk about electromagnet, okay, we need to actually coil the wire over an iron bar. Okay, so this is a solenoid. Okay, it's also called a coil of wire. Okay, so the rest of the items here are pretty new. Last week, do you remember I talked about this thing called the diode? Okay, this is a symbol of a diode. Okay, diode means this component only allow current to flow in one direction. Okay, so which direction does it allow? You see a triangle here, it's like an arrow. It only allows current to flow in the rightwards direction. So if you connect the plus on the left and the minus on the right, it allows current to move from left to right. But if you actually put a positive on the left and the negative on the, the positive on the right and negative on the left, nothing will happen because it doesn't allow current to flow in the opposite direction. Okay, this one is something like a valve where you learn in bio. Okay, so a diode itself is a component that only allow current to flow in one direction. So in this example here, you only allow the current to flow from left to right because the arrow pointing towards the right. Any question for me so far? Okay, in static electricity, we also talk about earth. Earth, okay, so this symbol is a connection to the earth. Okay, now the rest of these items are pretty new. Let me go through a few things first. Okay, let me go through this one, the fuse. Okay, the fuse, the symbol of the fuse looks like a fixed resistor. Am I right? But a fuse has nothing to do with a resistor. Basically, a fuse only allows a maximum current to flow through. Okay, so a fuse is a safety device that is found mainly in a plug, power plug, okay, or your plug itself. Okay, so for example, a common rating of a fuse is 13 ampere fuse. Okay, one example is the 13 ampere fuse. What does it mean? If you put a 30 ampere fuse in a circuit, if a current that is above this value, this thin wire inside the fuse will break and then your current will not flow through anymore. So it's a safety device. It doesn't allow too much current to flow through and therefore it will not spoil your devices. Okay, so a fuse has this symbol itself. Okay. The rest of the item, okay, the more important one will be this one. What does this mean? A light-dependent resistor. Okay, a light-dependent resistor. Okay, so you can see over here, inside here, there's a rectangle. So a rectangle is like a resistor. Okay, so what happens is this. When there is light, okay, when there is light, then there will be no resistance. Understand? So it actually allows current to flow through. But when there is no light, this device acts as a resistor. So less current will flow through. Did I make myself clear? Okay, so a LDR actually is a resistor that depends on light. Okay, you'll see a few of these in your exam. Another thing that you'll see quite often is the bell. Okay, a bell or heater. Okay, but this one is not heater, but this is the bell. A bell symbol is like this. Okay, basically it's a bell. It just produces sound. Okay, that's all you need to know about bell. And then thermistor. Thermistor is a component that produces heat. Okay, it's a component that produces heat. So when your current goes through, okay, heat actually is produced. Okay, hold on for a while. Okay, sorry. I just said something wrong. So can all of you erase the last statement? A thermistor is something like a LDR. Okay, a thermistor is something like a LDR. So a LDR, the resistance is dependent on light. Okay, so thermistor is like LDR, but the thermistor resistance is dependent on heat. Did I make myself clear? Okay, so a thermistor is a resistor that depends on the heat around it. Okay, the next thing I want to go through is the capacitor. Capacitor is similar like a battery, okay, but it's not a battery. Basically, it is a component that actually store excess charges. Okay, so so capacitor itself is something that actually try to stabilize your voltage. Okay, so can you see? Okay, sorry. So just now I told you about AC current, right? AC current, the voltage go up and down, up and down. So some people, they add a few capacitor in their diagram so that the AC will actually behave more like a DC. Because when there is more current, the capacitor will store up the current. When there's no current, you will let go of the current. Okay, so a capacitor is a device that stores your excess charges. Clear? Then this thing here is called a transformer. Okay, it's not the transformer that you see in the movie. Okay, this transformer is basically a device, Can you see down here? There is a left side and a right side, and they are not connected. Okay, they are not connected. There's a left side and a right side. So a transformer, actually what they do is to step up or step down voltage. So for example, on the right can be 100 kilovolt. On the left can be 10 volt. Okay, so what the transformer do is to step up or step down the voltage. Okay, well, you may ask me, why do I need to do that? Do you remember I told you all about the DC? Why is it not efficient? Because in long distance, in a very long distance, there is a loss in energy. Am I right to say that? Okay, so for long distance wire, the voltage is actually very, very high, like 100 kilovolt. So those wires that you see in Malaysia, not in Singapore, those hanging wire, they are all at very high voltage. Okay, why? When your voltage is high, your current will be low. Okay, so do you remember the definition of current? Means less charges moving through it every second. So when there's less current or less charges moving every second, it means that there will be less loss of energy. Okay, so to reduce losses, a lot of times we need to make your voltage very, very high. Okay, so when your voltage becomes high, your current actually goes down. Okay, so a transformer is used to change the voltage of your circuit, whether to step up or step down. Are all of you confused now? Okay, so now we go to the last one, potentiometer. Okay, potentiometer is something like a variable resistor. To me, they are the same thing. The variable resistor varies the resistance, whereas a potentiometer varies the potential. Okay, so for example, on the left side is 100 volt, 10 volt. On the right side is 0 volt. So between these 2 points, is the PD is 10 volt. So what a potentiometer do, it actually points in the middle of this machine or this component. So for example, if a circuit only requires 5 volt, you put this circuit right in the middle, and therefore it only produces 5 volt. Does it make sense to you now? So a potentiometer is something that varies your potential. It's very similar to a resistor, a variable resistor, where it varies the resistance. Okay, I took quite a while to explain all these symbols. So basically, besides understanding what all this does, you all must memorize how to draw all these symbols. Then you can draw circuit diagram. Okay, so take about 2 minutes. Can you tell me the 3 of these components that amaze you the most? Okay, tell me what are the 3 components that amaze you the most. Then we move on. Which symbols or which of the component you find interesting one? Okay, can you type out 3 things that amaze you the most? And then we'll move on. Oscar, you're very boring. You like the basic thing that you learn in primary school. Xiaoxing also, you go and choose the 3 things that you learn in primary school. At least Yiting is more interesting. Choose the 3 things that never learned before. Same as Bei Kuan learned the 3 things that never learned before. So I can tell who is the boring one and who is the interesting people. Okay, let me move on. Okay, I don't think I need to talk much about this. Okay, an open circuit is where current will not flow through the circuit itself, whereas a closed circuit, the current actually can flow through. So can you see over here on the right side? On the right side, there's a plus and a minus. Okay, sorry, this is not a closed circuit is a short circuit. Okay, sorry. So an open circuit is where a current doesn't flow through. Okay, so let me show you what is a closed circuit. Closed circuit you all learned before. Okay, a closed circuit will be something like this. I'll draw exactly the same thing. Okay, so can you see over here? This is the cell or the battery. It provides the energy for the whole circuit to run. So the whole circuit, there's no gap. This is a closed circuit and the light bulb will light up. Is that clear? So in this case, a closed circuit, a light bulb will light up. Now we talk about short circuit. This is something new. What is a short circuit? Okay, instead of drawing this thing, let me draw something else. Okay, now I want you all to look at this circuit on the right. If you see two light bulb, okay, your current actually move from plus to minus. So current move this way. Okay, current move this way. At this point here, the current have to make a choice to either go left or go down. So if the resistance of the two bulbs are the same, half the current will go to the left one, and the other half of the current will go to the bottom. So for example, if the current is 2 ampere, 1 ampere will go to the first bulb, the other ampere will go to the second bulb. Does that make sense? Now, if one of the bulb I take away and then I change it to a I change it to a wire. Now, when I only have one wire, if you are the current, all of you are the current, the 7 of you, you have two paths to go, either going through the bulb or going through with no bulb. Which path will you go? The one with bulb or without bulb? Okay, type up your prediction. If you are the current, you reach this point here, the same point. Okay, which path will you go? The one with the bulb or the one without bulb? Okay, Yiting correct, Xiaoxing correct, Oscar correct. How about the other 4 of you? Ryan, Howray. Okay, Howray, Ryan, well done. Last 2 of you. Okay, so basically there is no resistance on the right. That's right, on the bottom. So all the current will not need to think much. This one is like obstacle course. A bulb is like an obstacle course. So all the current will go through the bottom here. Okay. And because you're connected to a circuit, there's no resistance. Okay, let me go through this with you. Do you remember this formula? V equal to Ri. Okay. So if your resistance goes down to 0 and your voltage is still 1.2 volt, for example, what happened to your current? If your resistance now is 0, all your current will go through this path, there's no resistance, and you know that between left and right, the potential difference is 1.2 volt. What happened to your current? Will this value be very big or very small? Okay, all of you type it out now. Will this current be very big or very small? Okay, well done, Ryan. Well done, Yiting. Well done, Chelsea. How about the rest of you? Will the current be very, very big or very, very small? Well done, Oscar and Bei Kuan. Okay, so when you have something like this called a short circuit, your current will be very, very high. Okay, will be very, very high. Okay, and then you'll be very dangerous to the circuit. Okay, one example of a short circuit, one example is like this. You have a battery, you connect a wire to the top and bottom. So this is an example of a short circuit. Okay, so for example, this is 1.5 volt, bottom is 0 volt. if you were to put an ammeter here, you'll show a big value. And then you start to feel the battery and the wire start to heat up. Okay, that is not nice. Okay, and then it may cause fire and so on. Okay, so this is an example of a short circuit. I don't know whether you have experienced this before. If you want to connect a wire to a power supply without anything in between, current should be very high. So, and there's a reason why we have this thing called a fuse. For example, if I put a fuse here, which is the 13 ampere fuse, what it means that if the current goes beyond 13 ampere, the wire inside will break and the whole circuit will not work anymore. So it will protect the whole electrical appliance. Is that clear about this thing called the fuse? Okay, that's a function of a fuse, because sometimes in your equipment, your radio or your computer, a short circuit happens inside the component. Then current goes up very high. When current goes up very high, it may cause fire or it may burn other components because current very high, so that will spoil your component. So the presence of a fuse like this will actually protect your component from spoiling. Yes, it will not work. Okay, but when a fuse breaks, it tells you a few things. First, it protects your component from fire or from danger. Number two, it tells you that something is not right. Go and check. And then once you replace the fuse, it should be okay. Is that clear? Okay, so this is the thing about short circuit. Any question for me regarding short circuit? Does it make sense? Okay, so short circuit is not a good thing. Yes, the current will bypass the bulb will not flow. Okay, but it is not a good thing. It actually causes the current to increase by a lot, and it is dangerous to your component. Okay, so a short circuit is not a good thing. Okay, so we talk about current. The second part now. Second part is voltage. But in O level, we don't use the word voltage anymore. We either use EMF or potential difference. So EMF is to the source. Potential difference is to the component or the load. Another word for component is called the load. Okay, so source, including things like battery, dry cell, and so on. Okay, so the formula is the same. It is EMF or PD. The formula is the same. It is the work done over charge. If you think work done doesn't make sense to you, you can use energy. Okay, basically, because work done and energy, they are very similar. Okay, so the W can be changed to energy. If it makes sense to you, how much energy is required to push 1 coulomb of charge across the circuit? So basically, that is what EMF means. So the greater the EMF or the greater the PD, it just tells you that more energy is used up or more energy is supplied itself. Okay, but you don't say energy because that's not the proper definition. It's the energy per unit charge. Is that clear? Okay, so that's all about EMF and potential difference. Now, take a minute to tell me, any of you have any question about current and EMF? If you know these two parts very well, give me a yes reaction. If you are a bit confused, give me a no reaction. Yifan, are you okay? Ray and Ryan, are you all good? Ryan, are you there? Okay, great. Okay, so let's go into the resistance. Okay, the definition is the ratio of the PD over the current. Okay, that is the formula. Can you see? The ratio of the PD over the current flowing through it. Okay, the simple way to explain resistance, but don't use it as exam, is the greater the resistance, the less current will flow through it. Does that make sense to you? Okay, so in primary school or in lower secondary, we teach your resistance. The greater the resistance, the less current you will be able to flow through that component. Okay, the proper definition will be the ratio of the PD across the component to the current flowing through. Basically, it's just a formula, V over I. If you know the formula, you just explain the formula, that's the definition of resistance. Okay, so the greater the resistance, the less current will flow through. And then Ohm's law basically explain this relationship, okay, where the V and the I are directly proportional. Clear so far? Okay, so Ohm's law explain this relationship where the V and I are directly proportional, where the constant is the resistance. Okay, so for Ohm's law, those components will have a fixed resistance. Whereas for semiconductor diode as well as a lamp, they don't obey Ohm's law, okay, because they are not a straight line. Clear so far? Okay, so this is Ohm's law. Okay, so can you see over here? V over I is the resistance. So we are drawing I over V. So let me redraw the filament lamp. Okay, let me redraw. If I redraw it as V over I, the filament lamp will be in this manner. Okay, so if it's V over I, remember V over I is the resistance. The gradient tells you the resistance. So can you see over here? If I were to draw the gradient, it is increasing. Can you see that? The gradient increases. So what does this mean? As the current increases, the resistance increases as well. Understand? As the voltage also increase, but in this case, can you see the relationship? As the current goes up, the gradient goes up. So the gradient tells you it is the resistance. So for a filament lamp, okay, by right, when the current goes up, the resistance will goes up. Clear so far? Okay, so ignore this statement here. Okay, last week we also talked about this thing called the resistivity. Okay, resistivity. Okay, we mentioned before. The resistance is proportional to the length and the cross-sectional area. So the greater the length, the greater the resistance. Likewise, the greater the cross-sectional area, the lesser the resistance. Okay, so this is all that we mentioned last week. Okay, and anybody have any question for me? If not, we take a 5-minute break and then we'll do some question with you all. Okay, so I will pause for 5 minutes. Okay, let's start doing some question. And then we will, just to do a few questions today. So can all of you now start doing question 32 and then give your answer in the chat. Okay, everyone of you do question 32. Okay, Oscar, well done. Yu Ting, well done. Yifen, well done. Hao Rui, well done. How about the rest of you? Who is stuck? Please tell me. Xiao Xing, well done. So the formula we use here is V is equal to W over Q. Okay, so this is your energy. Okay, this is what you want to find. Okay, Ryan, well done. So the voltage is 12 volt. The current is, the charge is 100 coulomb. So what's your answer? Pei Huan, correct. Okay, so the answer is D. You rearrange, make W the subject, you should get the answer D, 1,200 joules. Is that clear? Okay, so this is actually what happened if you use if the conductor itself, okay, the component uses up 12 volt, and in that time 100 coulomb of charge flow through it. Okay, what happened is 1,200 joule of energy is being used up. Is that clear? Does that make sense to all of you now? Okay, to me it doesn't make a lot of sense, but if you follow the formula, that's how you get the answer. Okay, okay, now do question number. Hold on. Okay, do question number 33. Okay, you all may begin. Okay, Yufen, well done. Pei Huan, well done. Yi Ting, Oscar, well done. Ryan, well done. Hao Rui, well done. Who's the last student? Yeah, now wait for the last student. So if you all know this question, okay, the answer is A. Okay, because you measure the current along the circuit, and then you measure the potential difference. Okay, voltmeter measure the potential difference. You're measuring the difference between these 2 points. Okay, you're measuring the difference between these 2 points, and that's what the potential difference does. Okay, well done, everyone. Let's see whether you can do the next question. Okay, let's ignore this question for now. Let's do the next one. Okay, all of you go and do question number 29. You all may begin. Okay, Pei Kuan, correct. Yufen, correct. Qiao Xing, correct. Hao Rui, well done. How about the rest of you? Okay, so for this question, Oscar, well done. You're trying to find the PD. Okay, PD is V equal to Ri. Remember this formula or IR? Okay, so in this case, your R is 2, your I is in milliampere. Okay, so it's 190 times 10 to the power minus 3. Okay, from here, when you calculate, you should get 0.38 volt. So which of these four scale has 0.38? Okay, 0.3 is somewhere here. Okay, so only A provides 0.38 volt. Okay, the other answer you can use is 380. Sorry, not ampere. Okay, or you can find a millivolt scale, it should be 380. So the B and D is beyond 380. Okay, so B and D is not correct. Okay, we can also use C because 0.38 is somewhere here as well. Okay, but it is not very good because 0.38 is very, very small. Okay, for A is better because it actually shows you a greater scale of where 0.38 will be. For the C, you can't really tell it's 0.38. Maybe you can estimate it's 0.4. Okay, but for A scale, you can actually see exactly 0.38 in the scale. And therefore, the answer for 29 is A. Okay, well done. Let's do the next question. Okay, so far I'm very happy. You all are getting all correct. It's very different from last time. Last time it's like for a few questions, half correct and so on. So what happened? You all like electricity. Is it true? Okay, do question 31. You all may begin. So this one is also a very simple question. Which formula do you use? Okay, Hao Rui, well done. Qiao Xing, well done. Yifan, correct. Are you not sure about Yifan? Oscar, can you try again? Yuting, well done. Oscar, use the formula of I. What's the formula of I that we learned before? Okay, current is the rate of flow of charge. What's the formula? Okay, Oscar, well done. How about the rest of you? Okay, so for this question, you use this formula, or Q is it. Okay, then you sub in the whole thing, 60 coulomb versus 15 seconds, and therefore you get 4.0 ampere. The answer is C. Okay, is this a simple question? Okay, not that bad, huh? Okay, let's do the next question. How Ray, I didn't see your answer. Where are you, How Ray? Okay, all of you do question number 32 now. You all may begin. So you need to find the resistance of all three. So what's the resistance of all three? So can you all tell me, calculate the resistance of W, X, and Y, and give me the answer. Okay, I want you all to calculate the resistance of all three, W, X, and Y, and then give me the answer. Actually, this question don't need to calculate. Okay, so far all of you are correct. Ryan, Yufen, Oscar, Bei Kuan, Hao Rui, Qiao Xing. Okay, all of you are correct so far. Okay, answer for this is B. We know that when in series, it will be the biggest. Okay, and then if we are in parallel, they will be the smallest. Okay, so therefore from here, you know which is the biggest, which is the smallest, and therefore your answer will be B. Okay, just for practice. Okay, network X, you just add them together. Okay, so the resistance for network X will be 40 ohm. Okay, can all of you go and calculate W? See whether you can get the answer. Okay, everybody go and calculate the resistance of network W. See whether you can get the same answer as me. Oscar incorrect. Eating incorrect. How Ray, your unit is wrong. Yufen incorrect. You must inverse your answer again. Okay, what formula do we use? 1 over total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, E team, well done. Oscar, well done. Okay, so you sub in the R1, R2, R3 as 10, 20, and 10. So your 1 over total resistance, you get 1/4. Then you must inverse it, and therefore your answer here will be 4.0 ohm. Is that clear? Now, let's do network Y. All of you do that now. What is the total resistance of network Y? Well done, Chelsea. Well, you're very fast. Hooray, very good. Eating, well done. Oscar, well done. Okay, so when you, this part here, when you are both the same and in parallel, you actually effectively halve the resistance. If you use the formula, you will still get 5 as well. Okay, but if you know that there are two paths and they are of the same resistance, okay, your actual value will become half. Okay, so the answer for the last one will be 25 ohm. Okay, well done, all of you. I think all of you are very clear about this. Let's do the next question. Yeah, very happy today. All of you are getting it correct. Nobody is getting it wrong. Oh, this topic is very basic. Okay, let's do question number 30. You all may begin. Okay, question 30, you haven't learned the thing yet. Let me share with you something first. In practical electricity, 2 topics later, you will learn this formula, power is equal to VI. Okay, power is equal to VI. So in this question, you find the I first, which is power over V. Okay, you find the I first, which is power over V. So let me just go through the first step, because first step you haven't learned before. So 24 watt over 12 volt, your current will be 2 ampere. Okay, so based on this, can you calculate what is the charge that passed through the lamp? Okay, Qiao Xing, well done. Oscar, well done. Okay, Yufan asked me a very good question. When do we use P equal to V squared over R? We'll learn this in practical electricity, but I can go through with you today. Okay, Yiting, your answer is incorrect. How Ray, try again? Okay, so Yiting asked me, when do we use this formula? P equal to V squared over R. This formula. I'll go through, I will talk about this in a very short while. Bei Kwan incorrect. Yeah? How many seconds are there in 25 hours? Okay, so your next step will be Q is it. Your I is 2 ampere. Your time is in second. So you're supposed to convert 25 hours to second. So how many seconds is that? Okay, can all of you do that now? Okay, for Bei Kwan, do you understand how to calculate now? Same thing for Yiting. You understand why the answer is C? I think you forgot to add in another 60. You just multiply by 60 one time. You forgot to multiply 62 times. Okay, so for question 30, all of you understand now? Okay, so Yiting, sorry, not Yiting, Yifan asked me a question. Okay, she has seen this formula before. Okay, so let me just go through with you. Okay, so I mentioned today you have learned a new formula. You learn this formula P equal to VI. Okay, you will learn this in the 2 chapters later under practical electricity. Okay, so this topic you have learned also another formula. Okay, we have also learned another formula in this topic, which is V equal to RI. You remember this? Okay, so you want to find the power that is used by the component. We can multiply V and I, but not every time we have V and I. We may have V and R or R and I. So what do we do now? Okay, so another thing you can do is V is equal to RI. Can I let V become RI? So therefore, the power can be also V equal to RI squared. Is that clear? So all these formulas are the same. Okay, formula 1 is the same as formula 2. Okay, let me rearrange this. I is also equal to V over R. Okay, so can I change the I to V over R? So power is also equal to V times V times V over R, and therefore power is equal to V squared over R. So these 3 formula, 1, 2, and 3 are equivalent. They are the same. Okay, I'm going to box them up again. These 3 formulas are the same. Okay, just depends on what you have. You have V and I, you use formula 1. You have R and I, you use formula 2. You have V and R, you use formula 3. Okay, there's no need to memorize 1, 2, and 3. Okay, you memorize 1 plus this one, V equal Ri, you can come out with 2 and 3. Is that clear? So there's no need for you to memorize 4 formulas. You memorize the first 2 formula, the bottom 2 can be derived. Okay, Yifan, are you clear about this now so far? Yifan, you okay? Type something in the chat. Okay, then Yifan also talk about something that she's also confused. Why there's a time? Why is there a time inside? Okay, in chapter 6 or 7, do you remember this formula? Power is equal to energy over time. Okay, you rearrange, you get energy is power times time. Okay, these two are the same formula. Okay, do you remember these two formula? Okay, so if you want to find energy, we plug in the first formula into this. You get VIT. Clear? We plug in the second formula into this. You get RI squared T. You plug in the third formula into this. I'm talking about plugging in the P. You get V squared over RT. Okay, so can you see over here? I'm just plugging in the P into VI, RI squared, and V squared over R. Okay, Ethan, did that clarify for you why is there a T in the formula sometimes? Is that what you're trying to... So did I make it clear for you? Why is there a T? Why is there a time component? Okay, hopefully I help you understand better. Okay, so if some of my friends in school, they don't understand the logic, they memorize a lot of formula. Can you see down here, there are formula 1, formula 2, formula 3, formula right, and then bottom here another 3 formula. There are then another formula here 4. So in this page itself, there are actually 1, 2, 3, 4, 5, 6, 8 formulas to memorize. And some of my friends, they are very good at memorizing formula, but they still cannot get it because they don't understand why. Okay, all you need to know for this page is memorizing or understanding these 3 formula, and then you'll be able to, derive the rest. Memorize the first formula here, the second formula here, and lastly, this third formula. Okay, no, not this one. Yeah, correct. So these 3 formula you memorize or understand, you'll be able to come up with the rest of the formula. Okay, so this part we'll go through 2 topics later. I'll revise this with you again. Okay, so basically just need to memorize something new is P equal to V over I. Can you understand now? Your school teach you so fast until this page already. Okay, let's continue. The next question. So Yifan says that the school teach everything finished. Now revision for O-level. It's only April. O-level is November, right? Or October. The school is too fast. Okay, next one. Okay, do question number 32. Okay, do question 32. You want me to begin? Qiao Xing, you try again. 北宽 well done, Yu Fen well done, Oscar well done. So this topic involve prefixes. Do you need me to revise? Milli means times 10 to the power minus 3. Micro means times 10 to the power minus 6. Then the answer here is all in milli, is times 10 to the power minus 3. Okay, so you all remember Q is it. So time is Q over I. So can you all complete the working? Okay, Pei Kuan well done, Yu Fen well done, Oscar well done, Qiao Xing, Yu Ting incorrect, Qiao Xing correct, well done. Okay, so let me go through this with you. The Q in this case is 84 times 10 to the power minus 6. The I in this case is 35 times 10 to the power minus 3. Okay, and then after you do this, you'll get the answer 2.4 times 10 to the power minus 3. Times 10 to the power 3 is micro. Okay, so the answer for this will be 2.4. So not micro, sorry. Times 10 to the minus 3 is milli. So the answer will be 2.4 milliseconds. Answer is B. Okay, Yiting, you understand where it goes wrong? Okay, let's do the next question. Do question 33. You all may begin. Question 33. Okay, 33 should be simple. How Ray, well done. Yiting, incorrect. Do you need me to explain the formula of PD? PD is what over what? Even incorrect also. So you think your formula is correct. So which of these four answers explains the formula? Okay, Yifan, well done. Yiting, you got it now, well done. Understand now? Qiao Xing, well done. How about the rest of you? Okay, those who are fast, look at 34 first, but don't give me the answer. Bei Kuan incorrect. Okay, so PD, you have learned before. The formula is the work done to drive one unit charge across the component. So very simple for this, the answer will be D. Based, if you know your formula, you will know that the answer will be D. Correct or not? Okay, I don't know why some of you say A, some say B. Okay, now everybody do question number 34. Okay, now we will just stop here. The last question we're going to do today is 34. Then we will continue the other question next week. Okay, do question 34 now. Bei Kuan correct. Yifan, try again. Ryan, try again. Qiao Xing, well done. Ryan, try again. Yiting, well done. Yifan, Oscar, try again. Okay, do you remember the formula? Resistance is equal to resistivity times L over A. Okay, so what happened is this. The length is 2 times. So it is 2 times the length. The cross-sectional area A is 4 times. So this is 4 times. So your resistor itself would increase 2 times and then decrease 4 times. So what will be your effective, what is your resistance of Q later on? You all know what I mean? The length is increased 2 times, so your resistance times 2. Your area is increased 4 times, so your resistance is reduced by 4, divided by 4. So what is your final answer? Okay, so if the length increased by 2 times, you times 2. Okay, the area is increased by 4 times, you divide by 4. So therefore your answer will be, or we try again? Okay, Oscar, well done. Ethan, how's your answer? Ryan, what's your answer? Auri, are you there? Okay, Ethan, well done. So you multiply by 2 divided by 4, and therefore your answer will be B. Is that clear? All right, before you go, I want you to tell me how much you learned today out of 10, and the one thing you learned today. Okay, tell me. How much you learned today out of 10, and one thing you learned today. Okay, once I call your name, you may leave the class, and thank you very much. Okay, so these 2 questions you can share with everybody, so everybody can see what you learned today. Oscar, that is learned last week, not today. Okay, Oscar, you may go. Yiting, you may go. Thank you. Yifan, you may go. Chelsea, you may go. Wei Guan, you may go. Hao Rui, you may go. All right. Thank you, everyone. Good night and goodbye. Okay, Ryan, you may go.